The following content is for entertainment and educational purposes only. It does not constitute means for diagnosis, healthcare advice, nor treatment. Make use of a qualified healthcare professional for such purposes.
Good afternoon, everyone. My name is Dr. Charlene Ortiz, and today we're going to start a new lecture. This lecture represents that of chapter 12, I should say, and that is that of factorial experimental designs. Now, we have covered this a little bit more in detail in some labs that we have done previously, but today we are going to cover this very extensively. And what are the topics that you can expect for today and for our future lectures? Notice that we're going to define and we're going to look into the interest as to why is it that we need to test multiple factors in the same experiment. We're also going to talk about how sample selection is relevant for experimentation. And we're going to talk about different types of experimental designs. And within this aspect, we're also going to talk about the ethics, for example, participant fatigue in regards to factorial designs. And we're also going to talk about main effects and interactions. So any questions about the topics that we will cover today? All right, beautiful people, let's get started. So if we revert to our presentation, notice that one of the first things that we have to do is define what a factorial design is. Notice that the intent of this specific lecture is for us to describe situations in which managing and looking into the manipulations of the levels of two factors, that is what we're trying to do, right? We're trying to define these factors whenever we are looking within the same experiments. So the first thing we need to do is define the terms, right? That's always in our best interest. Notice that a factorial design, as the term suggests, notice that what I am interested in is in this specific design. This design is geared towards the participants that are being observed in groups that are created, the combination of levels of two and more factors, right? In regard to two or more factors. And what does that mean, simply put? It means that within this specific experiment, I'm not looking to just one factor that I am trying to manipulate. Generally, in this specific design, I'm looking for two factors that I am interested in manipulating, right? So the combination of levels or two or more factors. So notice that previously we have talked about other designs that only involve one factor. So for example, one independent variable with one level, and then that dependent variable. But notice that here we may have either multiple variables, so we have multiple variables, or we have one independent variable that has many levels to them. So if we revert back to your presentation, let's define what a factorial experimental design is. Notice that in this specific regard, what I am interested in, I'm going to have this research design, and how am I going to create these groups? How exactly am I going to create the groups? Well, the groups are created based on the manipulation of those levels, right? So the groups are going to be created based on that manipulation. Notice that what I'm referring to, it's either more than two factors or two levels, right? So we either have two or more factors, or we also have multiple levels. Notice that contrary to other methods that we have explored before, So for example, the within research and within and between research designs, notice that here we can have both. So for example, we can have the same or different participants, right? So there is a chance that you can choose whether or not you want to observe the same participants across your experiment, or that you're interested in observing different participants. So that is another aspect that we can consider within the factorial experimental design. Notice that these participants that I am trying to observe, right, they are going to be exposed to the process of randomization. And again, notice that we again are going to see the between subjects factor, and we're also going to see the within subjects factor. And how is it that we're going to observe that? Well, remember that because of randomization, right, we're going to use randomization, which is generally seen in the between subjects design. But not only are we going to control for randomization, we're also going to control for other aspects of internal validity and external validity threats. But in this specific case, let's focus on internal validity. So notice that in making use of controlling timing and order effects, notice that we are also making use of the within subjects factor. So any questions about the factorial experimental design or its components and characteristics? All right, good deal. All right, so if we go back to your presentation, notice that we can also define, we can also look into the complete factorial design. We can also refer to this specific design as the completely closed design. And what does that mean specifically? Notice that the participants that are observed in each level, the participants that are observed at each level of both factors, right? So they're going to be observed in both factors. Notice that they will be included within each level of the other factor. Notice that because of that, we're going to have a combination of levels, because I am observing those participants in every single level possible. So, any questions so far? Good deal. Fantastic. Now, in regards to an experimental design, let's look into aspects. Let's look into aspects as to how exactly are we going to select these samples? How exactly are we going to gather these samples? Notice that the appropriate sampling method for this specific design, for the factorial design, is particularly geared towards an experiment, right? So we would draw a sample. We would draw a sample from a specific population. Notice that this specific illustration that I am showing here refers to a particular draw for a 2x2 factorial design. Notice that we have the different groups. So for example, we have from the sample, we drew group 1, group 2, group 3, and group 4. And notice that after we drew that sample from the same population, we are going to then randomly assign. We are going to randomly assign the participants to each group. So any questions so far? Now, something that I need to remind you of, is that there are some instances in which we can select one sample from the same population and then assign them either the same participants to each group. So for example, I would have, say, Peter, Jessica, Yolanda, and then I do the same thing for here. So we will have Peter, Jessica, Yolanda, and the same deal with the rest of them. So notice that I can either assign the same participants to each group, or I can also say, very similar to the between subjects, the sign, I can say, okay, so I just want Peter, Jessica, and Jolanda here, and I want Louise and Jamal and Peterson here. So notice that we could either have the same participants, or we can start drawing and randomizing in each group individuals who are from different, they are different persons indeed, and they are not necessarily the same persons. Now, when we are thinking of factorial designs, we actually very briefly just spoke about this, but we're actually going to talk about it a little bit more in detail. So in regards to that, we are going to cover the next factorial designs. Notice that we are going to look into the between subjects design. We're going to look into the within subjects design and the mixed factorial design. I do want to remind you that because they are indeed different designs, there are slightly different requirements. There are slightly different requirements in order for each to be considered experimental. So let's look at the characteristics of each individual aspect, right? Let's look at each individual group. Notice that in regards to the between subjects design, within the between subjects design, what I am trying to do is that all factors are between subject factors. Notice that I am going to look into the differences between one factor, the next factor, and the next factor. What can happen with this specific design? In using this design, we are trying to manipulate the levels of both factors across the levels of each factor to create a specific group. So if you recall from the beginning of our lecture, remember that I mentioned that in order to create our groups, that is going to be based on our manipulation. And that is the same case here for your between subjects design. Notice that as we are creating those factors, right? Creating the levels of each factor, we're going to create our groups. Afterwards, what you're going to do is randomly assign different participants. And I'll say that again. With between subjects design, what we're trying to do is assign different participants to each group. Let's talk a little bit more about that between subjects design. Notice that in this specific regard, if we revert to your presentation, notice that we're going to find those multiple levels once again. So 2 or more levels. Notice that when I do set combination, I'm going to create 2 groups, meaning that different participants are then going to be part of each group. But remember that I mentioned that we need different requirements. We need different requirements for each of these 3 different designs to be considered an experiment. So let's explore them together. Let's explore the requirements of the between subjects design to be considered an experiment. So what are your responsibilities, right? What are your responsibilities in order to meet set requirements? Well, first and foremost, something that you should be acquainted with is that in order for a design, a procedure to be considered experimental, first thing that we like to do is we must manipulate. We must engage in that manipulation of all of the levels of your factor, right? And what does that mean in the Queen's English? What that means is that whenever you are trying to do that manipulation, you're going to do it for all factors. So not just on the one specific factor, and then, well, I just manipulated one variable, and I couldn't manipulate that second factor, so I must be okay. Absolutely not. You should be able to manipulate all of the variables, and on top of that, you should be able to manipulate all of the levels of said variable. So notice that it's basically an all or nothing approach, right? You should be able to manipulate all of the variables. What is another characteristic of the between subjects design? What is another requirement in order for it to be considered experimental? Notice that you will have to cross the levels. You will have to cross the levels of the two factors to create the groups. So for example, if I were to say I have factor 1 and factor 2, and I have level 1 and level 1 for the second factor. So notice that now when you're creating your groups, you should be able to cross in between set groups. I should be able to see those different levels based, or I should say the groups based on each level. So if I have factor 1, level 1, factor 2, and level 1, and then level 2 for factor 2, level 2 for factor 1, notice that I am able to cross the levels in order to create those groups. Any questions so far about those two requirements and your responsibilities as a researcher? Fantastic, fantastic. Notice that, as most of you know, and for those watching at home, remember that another important characteristic of the between subjects design in order to be considered an experiment is that we must randomly assign. We must be able to randomly assign participants to each group. And you're wondering, what is the intent, right? What am I trying to accomplish? What you're trying to accomplish is we're going to try to see if the differences in the groups, can be measured, right? The differences in that independent variable and dependent variable, I should say. So think about your factor, right? Factor 1, factor 2, level 1, level 1, level 2, level 2. Notice that the intent of having those groups after you created the level of that specific factor, your intent is to measure, are there indeed differences? Are there indeed differences when I compare group 1 of level 1, factor 1, level 1? Are there differences between that group 2? So for example, factor 2, level 1, and so on and so forth. So your intent is to be able to measure that dependent variable across those groups. So any questions so far? Good deal. Something that I would like to measure, something that I would like to mention, I should say, is that what we are trying to do in this specific regard within the between subjects design is that you can actually determine the total number of participants, or your capital N. Notice that you are able to determine how many participants would I need in order to conduct this factorial design. And how exactly would you do that? How exactly can you find out how many participants would you need in regards to the between subjects factorial design? So notice that it's actually pretty simple. All you have to do is multiply the sample size by the number of levels for each factor. So I want you to imagine that you have 10 participants, right? You have 10 participants for your study. And notice that in this specific case, we're doing a 2x2 factorial design. So all you have to do is basically multiply 10 times 2 times 2. That will give you a total of 40 participants. You will need a total of 40 participants in order to satisfy each group that you were trying to look into. So for example, factor 1, factor 2, level 1, level 1, level 2, level 2. So that is 4 groups, and you would need at least 10% in each group to satisfy that factorial design. So let's move on into another research design. And in this specific case, we are going to be talking about the within subjects design. There are no questions about the between subjects design. Notice that in this specific regard, within the within subjects design, there are some similarities. So for example, there are some similarities with the between subjects design. First and foremost is, well, before I continue, there's also significant differences, and they come because of the different aspects, right? The different requirements that we're going to have in regards to the within subjects design. The first thing that I like to mention in regards to the within subjects design is that when we're thinking about the within subjects design, all of the factors are considered within subject factors. If you recall previously, when we were talking about the between subjects design, notice that I mentioned that they were between participants, right? They were between these different groups. So group 1, group 2, group 3, and group 4. Notice that in this specific regard, all of the factors are going to be within that same factor, Notice that in using this specific design, the within subjects design, notice that what I'm trying to do is, again, manipulation, because it is still experimental. So what I'm trying to do is manipulate both factors, both of those factors, and cross those factors in order to create different groups, similar to what we did previously with the between subjects design. But because I am measuring the same people in all of those groups, so Peter, Jessica, and Robert are going to be in factor 1, level 1. Peter, Jessica, and Robert are going to be in factor 2, group 2. And then I'm going to measure the same people. Notice that because of that concern, now I'm going to have to deal with a specific problem. Notice that I will have to control. For issues concerning aspects of timing and aspects of order. Notice that in previous lectures, and I'm also going to have that linked in the description below, and for those of you who are in class, those lectures are already posted under your class's canvas. Notice that in regards to the within subjects design, one of the limitations that we had is because I'm using the same people to observe group 1, group 2, and group 3. Notice that we deal with validity threats because I am observing the same group of people. So if I am observing the same group of people, perhaps the order is going to be a problem. So if we have Peter, Robert, and Jessica, and today I decided to, instead of Peter, Robert, and Jessica, I'm going to do Jessica, Peter, and Robert. Notice that if I start switching that order, that may lead to a difference. That may lead to variability that I was not expecting, because the variability that I'm hoping to get is that variability because of the manipulation that I engage in the independent variable that I'm later going to measure within that dependent variable. So notice that the order can indeed affect the results. So now we're having to deal with that specific problem. And you're wondering, well, if I'm dealing with that specific problem, why is it that I can just go to a between subjects, right? I don't have to deal with that necessarily with my between subjects design. Well, with the notion that we are doing a within subjects design, sometimes we are interested in observing the same group of people. Sometimes we aren't interested. So say, for example, you guys, right? I am interested in observing the same group of people across a couple of months, right? So your grades, right? So I'm interested in observing the same group of people. I don't want to observe different groups and compare them. I want to observe the same group of people and be able to do a comparison within this specific class, not between different classes or different sections. So notice that, again, we would have to create the groups based on the fact that the same participants are going to be observed in each group. So for example, Peter, John, and Jessica, and my group 2 is still going to be Peter, John, and Jessica. Contrary to our previous example, notice that previously we will be comparing different groups, different participants, right, in the groups. So Peter, John, and Jessica in group 1, and then Louise, Jamal, and Peterson are going to be in group 2, whereas here is the same people. Notice that we do share some similarities when it comes to the within subjects assigned and the between subjects assigned. We are also going to find that similarity, which is we are trying to manipulate the levels of each factor in order for my design to be considered experimental. Notice that we also are trying to look into crossing the levels of those two factors. And we are also interested in aspects of control, but notice that in this specific case, the control that I'm trying to look into is the order effects, the order in which these individuals, for example, are presented, say, the stimuli for my experiment. Say I'm interested in looking into, let's say, the order of the items for the assessment and that measurement of that dependent variable. So I'm also concerned about that as well. I can be, say, for example, concerned with the order of, say, it's Peter going first, then Jessica, then Billy, and I hope you guys remember Billy from our last lecture. He said hi. I'm going to start using him in other lectures, so he's going to be hanging around. So notice that in me changing the order, and the individual is always Peter first, then Billy, then Jessica. So changing that order can also impact that measurement, that variability when it comes to the dependent variable. So if I don't control for them, if I don't control for those differences in regards to order, who is to say that my manipulation indeed had that effect on that dependent variable? So any questions about that? Good deal. Now, similarly, how we calculated the amount of participants that we needed, which was in regards to the between subjects assigned, which all we did to calculate our capital N was going to multiply the amount of participants times the factors that I had in my study and their levels. So factor 1, factor 2 has 2 levels. Factor 1 has 2 levels. Factor 2 has 2 levels. So for a 2 by 2 design times the participants. In regards to a within subjects design, that's actually super easy. Why is that? Well, because we're already observing the same participants, right? We're already observing the same participants. So notice that the sample size in each group, therefore, is going to be the same because the same participants or subjects are being observed in each group. So there, it actually works out because I don't have to do that calculation. So let's revert back to your slides. Now, we talked about between subjects, we talked about within subjects. Notice that in this specific regard, whenever we are trying to make use of the mixed factorial design, what we are trying to look into is that if I were to define it, I am simply trying to look for at least one between subjects factor, and the next one would be at least one within a subjects factor. So notice that it is a mixed factorial design because I am looking for at least one aspect, one factor that would be considered between subjects, and then another factor that would be symbolic and representative of the within subjects factor. In this specific regard, what exactly am I trying to accomplish? Well, one of the things that I'm trying to accomplish is, of course, that manipulation. I am still interested in the manipulation of both factors, cross the levels of each factor in order to create the group. So it's the groups, I should say. So it's still very similar to the previous instances that we explored before. Notice that we are also going to have the same concerns of randomization. Let's look into this specific factor. Notice that contrary to the between subjects design, notice, or between subjects in the factorial sense, notice that different participants are going to be observed at each level. So contrary to our within subjects, notice that here we are similar to the aspect of the between subjects because I am interested in observing different participants. Notice that we're also going to include that one factor. We're going to include at least the one factor of the within subjects design. And notice that we are going to repeatedly observe. Notice that just like in the within subjects, I'm going to repeatedly observe across the levels of that factor. So notice that we have basically the best of both worlds. Not only am I observing different participants, but I'm also going to observe that repetition, right? Just like you would in the within subjects, you are repeating, you are using the same participants. So it's basically one of the aspects that looks really similar to both the between and within subjects. Now, if we revert back to your slides, as I mentioned earlier, you are going to have at least one factor of the within subjects and the between subjects. But in keeping with our previous examples of how is it that I calculate the total number of participants or subjects, notice that in this specific case, in our sample, capital N, in regards to this specific experiment is we're going to have an equal to the sample size. So whatever the sample size was, and times the number of levels of the between subjects. So if you recall for our between subjects, what we mentioned was that between subjects, we will multiply the number of participants times the different factors. So it will be very similar to how we calculated the between subjects in regards to the amount of participants. So let's talk a little bit about what are the requirements, what are your responsibilities as a researcher to be able to name this mixed factorial design as an experiment, right? So in regards to those requirements, we're going to find again that manipulation. We would not be able to call something an experiment if we do not manipulate, right? And again, we want to be able to manipulate all of those levels, right? All of the levels of each factor. So again, not because you're manipulating one level and not the other, not because you're manipulating just one factor and not the other. You want to be able to say that you are manipulating all of those levels. Notice that similar to our previous instances, you're also going to create the groups based on the cross levels, right? Based on you crossing those two factors. So it's again immensely similar. Notice that this specific regard is similar to that of between subjects, and is I'm going to randomly assign the different participants to each level. Notice that you're only going to do that with the variable, or I should say factor, that was the between subjects factor, the one that you have already identified as the between subjects factor, which clearly makes sense because you're trying to identify different participants. So because of that reason, it makes sense that you will randomize based on the characteristics of that between subjects factor. But if you recall, when we were talking about the within subjects, if you recall, one of the limitations that I mentioned to you is that now we have to address aspects of control. Therefore, in order for the mixed factorial design to be considered an experiment, now I have to deal with the limitations of the within subjects participant that is inside my mixed factorial design. So now I have to control for order effects. And why is that? Well, because within that factor, within my within subject's factor, I'm observing the same participants. And because of that, I do not want to engage in the error that because of order, that's what led to the variability in regards to that dependent variable. I want to ensure or maximize the likelihood that it was indeed my manipulation what affected the dependent variable in that mixed factorial design, and not because the same participants were observed. Now, you did hear me say that there are some issues when it comes to the factorial design. What are some of the issues that I can encounter, right? What are some of the issues that I can encounter? Well, notice that one of the issues that you will come across is that you will be placing a significant burden upon your participants, right? Notice that this is particularly important. It is particularly important because the number of groups that you are creating are going to be based in that combination of levels. So because of that, you're going to cause and impart certain fatigue with your participants. Now, let's look at other aspects that should be considered ethically whenever you are conducting a factorial design. Notice that if you have a large number of levels that are being combined to create the group, the greater the demands on the participants. Notice that now, for example, if you have factor 1, and now you have level 1, level 2, level 3, level 4, and so on and so forth, and you keep that continuation, notice that now these participants are going to have greater demands because they are engaged in more levels. Their participation is going to extend. The general demands are going to be greater. So for example, the exposure to, say, that manipulation, now they're going to be exposed to more levels. So that can engage in fatigue. So don't forget that because of the greater demands that you are placing, the greater the burden that you're going to place upon your participants. So any questions about that? Fantastic, fantastic. Now, perhaps one of the main goals that you have as a researcher, I would say just in general, is that you want to ensure that it was indeed your manipulation and not an extraneous circumstance that led to that difference. Because of that, your main goal in this specific case is to minimize the possibility that it was indeed the individual differences that led to that variance, that led to those differences in the measurement of your dependent variable. Notice that when we're thinking, if we revert back to your slides, notice that when you're thinking about individual differences, every time you hear individual differences, I also want you to hear between subjects. And what is that? Well, because when I had the different subjects that I mentioned, so for example, in group 1, I had Billy, Peter, and Jessica, and in group 2, I have Louise, Jamal, and Peterson. Notice that because they are different people in each group, their individual differences that they bring in as research participants can indeed affect that variance, will lead to some form of variance. So whenever you're thinking about the individual differences, I also want you to hear between subjects design. Notice that how can I minimize this issue? How can I address this issue? That it was indeed individual differences, right? The characteristics they bring in. How can I minimize that? Those characteristics that they brought into the research are going to affect my research. The first thing that I can do is use different strategies, work on my methods. Notice that I would be responsible in regards to creating the methods of my experiment. So because of that, I could use different strategies in regards to my methods. Notice that another thing that I could do in order to control for those individual differences and minimize the impact of those individual differences is statistically. I can use test statistics in order to address the minimization of these individual differences. If you recall our test statistics, remember that test statistics are there to ascertain and determine what is the likelihood that something else other than my manipulation contributed to that variance, right? So we use T statistics in order to ascertain if in fact, was it me or was it an individual difference that was present that led to that variance, that led to that variability. So any questions about that? So as an example, we can make use of the two-way analysis of variance in order to minimize for those concerns. So in keeping with an ANOVA, let's talk a little bit more in detail in regards to our ANOVA. Notice that in this specific regard, what we're trying to do with the ANOVA is analyze the variance in that dependent variable in regards to the creation of those groups by combining, I should say, the levels of two factors, right? Combining the levels of those two factors. Notice that this statistical procedure, the ANOVA, is not left just for experiments. We could use it for quasi-experimental approaches, but we need to take that with a pinch of salt. Because if you remember anything from quasi-experimental approaches, notice that strictly speaking, a quasi-experimental approach cannot control for individual differences. So notice, yes, we could utilize that ANOVA to look into the individual differences and how was it that it impacted that dependent variable. But we have to take that with a pinch of salt because inherently a limitation of the quasi-experimental approach is that it will not control and will not address individuals' differences. Why is that? Well, simply because whenever we're talking about a quasi-experimental approach, notice that what we are trying to deal with is the lack of manipulation. One of the examples that I like to give students is that notice if I want to study trauma, for example, I cannot control for that difference that you come in with. So for example, I cannot give my participants trauma, right? Because perhaps that will be considered unethical and illegal. So because of that, I am unable to control for that individual difference. So sure, I can measure with a T statistic, but can I truly control for it? And because I cannot control for it, this aspect, the quasi-experimental approach cannot be used to determine and demonstrate cause and effect. Notice that when we are thinking about an ANOVA, I want you to think about the letter F, and notice that we are going to look at what is the variance of that individual difference, right? Notice that in the numerator, we're going to have, okay, what are the differences that these individuals carry? And in our denominator, we're going to have, okay, what are the differences that can be attributed to error? So any questions about that? Good deal. Now, we did talk about how and why a quasi-experimental approach cannot be considered as an aspect that we can utilize to demonstrate cause and effect. But if we did want to show cause and effect, particularly in the fact of a factorial design, remember that in this specific regard, what we would have to do is control. We would have to provide control for both levels, and both levels must be present for the factorial design to be an experiment. And if I can show that it's a true experiment, I can also show cause and effect. So earlier, we were talking about aspects of the two-way factorial design. And let's cover it a little bit more in detail. Notice that a two-way factorial design is in which we are creating those groups based on our combination or crossing of the levels of both factors, of two factors. Notice that in order for us to utilize this design, we can determine three sources of variation. So I like to call this your truth, my truth, and what actually happens, right? So notice that in a factorial design, we're going to be looking into the main effects, which would be what actually happened, and your truth and my truth, right? So I like to think about the factorial design as to what are the sources of variability. So let's cover these sources a little bit more in detail. Let's look at main effect. What is the main effect when we are thinking about a factorial design? Notice that that main effect is exactly what we're here for, when it comes to a factorial design. Notice that you wanted to see whether or not the two main effects, the first factor, factor A, and one factor for factor B, are indeed sources of variation. Notice that the second aspect could be one interaction. Perhaps the two main effects didn't have an effect, right? So factor A and factor B inherently didn't have a specific form of variation, but maybe if we combine the levels of factor A and factor B, then we may be able to see an effect. Then we may be able to see an interaction. But another source of variability is clearly error, right? So error can be yet another source that could be the aspect that is influencing that variation. Generally, when we are thinking about error variance, we are thinking about the variability that is attributed to those individual differences. So notice that the first source of variation is the two main effects. So factor A and factor B. Notice that perhaps factor A and factor B did not necessarily show that interaction, or I should say effects. But then if we look at the combination of different levels, then we found variability, or variability simply happened not because of you, but because of those individual differences. Now let's look at them a little bit more in detail. Let's look at main effect a little bit more in detail. Notice that main effect, and again, that's factor A and factor B. Notice that when we are thinking of the main effect, notice that we are looking at that mean difference, right? That average difference across the levels for just one factor, for a single factor. Notice that if I run my statistic and it comes across as significant, what a significant main effect can try to tell me is that the group means significantly vary across the levels of the one factor, independently and without necessarily that influence of the second factor, So let's take a look at a potential illustration. Notice that the first factor, right? The first factor for this design is, notice that the student studied, right? The student studied for a quiz. And notice that the second factor is attendance. Notice that here I'm going to create my four groups, right? So group 1, group 2, group 3, and group 4. So notice here we have that first group. So notice that factor A, so the person did not study, right? The person did not study and also had really low attendance. Notice that in this specific block or group here, notice that the person did study, but had low attendance. Notice that in our third aspect, notice that the individual did not study for their exam, but did come to every class. And lastly, in our fourth section, notice that the student did indeed study, and not only that, had a really high attendance. Notice that in regards to the main effects, if we only look at factor A, right? So here is factor A. If we only look at factor A, what we're trying to say is that the students who study earn higher quiz scores regardless of their attendance. So if we revert back to our previous slide, notice that we are looking for that significance independently of that second factor. So notice that here, because the students studied factor A, they still had higher scores irrespective of factor B, therefore their attendance. Now, we can also see, for example, if we were only considering factor B, so B1 and B2. Notice that in this case, instead of factor A, it is factor B that was indeed significant. What we would say is that students that had high attendance earned higher scores regardless of how much they studied. So notice that these main effects could be individual, regardless of the impact of the other variable. Now, like I mentioned earlier, sometimes we're going to have interactions. Notice that when we have interactions, what we're trying to say is that the variation that you found in that dependent variable is going to be associated. In regards to how the one factor may be influenced, may depend on a level or the levels of the second factor. If you remember, we talked about main effects. And when it came to main effects, what I mentioned was that we're going to find a significance irrespective of the previous factor. So if you recall, we'll have factor A, and factor A provided that significance in variance irrespective of factor B, or vice versa. Factor B showed a significance irrespective of factor A. But now let's look a little bit more in detail in regards to interactions. So if we revert back to your slide, notice that in this specific case, the variation is going to be influenced based on the one factor because it either is influenced, it depends upon other levels of the other factor. Notice that when we are referring to that interaction, what we are referring to is that perhaps that factor would not be significant had it not depended upon a level or had it not been influenced by another level of that second factor. And what does that mean? What does that mean that that aspect, that factor is going to be influenced or it's going to be dependent upon another level? Notice that what is going to happen is that whenever we find that significance, whenever we find significance in that interaction, what that significance specifically is trying to tell us is that the group means very significantly across the combined levels of those two factors. And I'm going to give you an example of what that looks like. Notice that contrary to our previous table and illustration, notice that now I'm not looking strictly at factor A and factor B. Now, what I am looking for is if my factor is dependent upon or influenced by a specific level. So previously, what we were looking into was the mean, right? So we were looking at the mean here for the main factor for A and the mean here for the main factor of B. But notice that now we're only looking individually. We're looking at each level. Previously, we were only looking at the means of each factor. Now we're going to look a little bit more in detail in each level. So let's start with the interaction of factor A, but simply with the second level of factor B. So what we would say is that there is a specific influence, right? We state that students with high attendance and those who did study score higher. So notice that now there is an interaction. Notice that there is a specific interaction. Let's look at the first level, right? So let's look at factor A and only compared to the first level of factor B. So in this specific case, should that be significant? Notice that we would say that among the students with low attendance, those who did study scored higher. So notice that now we're seeing yet another interaction. Let's look at the levels of factor A. So let's look at factor B and the first level of factor A. What we would notice is that if indeed this was significant, what we would say, students who did not study, students that amongst the students who did not study, those students with high attendance scored higher. And lastly, let's look at factor B and our second level of factor A. What we would say is among the students who did study, those with higher attendance scored higher. So notice that now we're not simply looking at the mean, right? We're not simply looking at the mean of each factor, but rather we're trying to see is there interactions. For example, if I show up to class, and I study harder, right? So notice that there is an interaction. There is an increased significance, right? There's a significant likelihood that I will score higher. So let's look into one of the last factors, right? Let's look at the last factors of variance. That is error. Error, as I mentioned earlier, notice that error variance, it's generally largely attributed to individual differences. Notice that in this specific regard, when we are thinking about a factorial design, remember that this is generally associated with the difference in participant scores, and it could be within each cell, And this is something that we generally refer to as within groups variability. Now, we have talked about within groups variability before, but let's look at an illustration when it comes to that specific variability. Notice that in this specific regard, what we're going to come across is, notice that here we have study for a quiz again as our factor A, and for factor B is attendance. Notice that now what I'm trying to ascertain is in regards to each student, right? In regards to each score that each student had. So for example, here's a student who did not study, right? And did not have high attendance. So notice that that person's score was a 1. Notice that in the second instance, we're going to say it was Billy again. So notice that Billy, in this regard, did not study for a quiz and also had short attendance and so on and so forth. When we're thinking about error, we are thinking about the individual differences within each person, right? We're looking at to how do the individual differences contribute to that variance compared to the individual differences of this variance and this specific score and this specific score. So notice that what we were trying to do is identify whether or not the individual differences between Peter Billy, Jessica, and so on and so forth, if these individual differences where in fact those main effects occurred.